Okay, this is a BOP by Kepco, and this is one I got used. Too cheap because it's got an issue, but I ended up figuring out what's wrong with it. Got the service manual. If you turn this on and have this in voltage mode, it's completely up here past 50 volts, and you can't control this with the voltage knob here. So I've debugged that, and that's why I was showing what happens here. That's the raw supply. Those are the two power modules. And it turns out one of these right here has got a short in the PNP. And first I pulled the Darlington over here, and it still was what I call up against the rail. This is the supply rail. So it's way up here before regulation. So this puts out, this is a 50 volt supply, and so you've got about 66 volts or 67, somewhere around there. I think it's like 75, but this is after the transistors. So okay, I've got the Kepco BOP working here. It's a 50 volt model. There's the voltage limit I've set with this. There's putting out 0 volts. There's minus 50. This unit was up against the rail. It was putting about 67. It's about 65, 66 volts out because one of these sets of PNPs here is shorted out. This is a 400 watt model. There's two. This is a 200 watt module. This is a 200 watt module. This is a full rack mount. And just by using the service manual, I've gone through and kind of unplugged this one module, and then it doesn't go up against the rail. So this is a 200 watt module. This is another 200 watt module. But because they're daisy chained together, but when you unplug this guy's dead. So I've got some little jumpers in there that connect these two greens together, and then the drives for the bases of the transistors. So one of the modules has got 6 transistors here, 6 transistors here. And the other module's got 6 transistors here, 6 transistors here. So it's got 2N6609 PNPs and then 33773. So in the manual, it had me going through and pulling one of these Darlingtons out, and that didn't do it. It was still up against the rail. So it says also to check the output transistors. So I unplugged it, and it's still up against the rail, but I didn't realize how the way they're daisy chained together. So right now, this module here is, this part of the module is undone. So I've got it working. So many thanks for Kepco. I ordered their manual, and it was better than I thought. So a bipolar means you can either source or sink current. So this is 50 volts up, and then this is 50 volts down. So if I put this into current mode and I adjust this here, the voltage goes back and forth because I don't have a load here. So if I put a resistor in here, this is going to go linear and vary the current versus the voltage. But since I don't have I just have the sense wires on there, this is zipping back and forth. So this is in voltage control mode. These are used to kind of do testing. You can use them to test servo motors and things. They make some models that are designed for capacitive loads or inductive loads. It's like basically a big speaker amplifier. for bench testing equipment. They're very well made. Kepco is a very, very good brand. Been around for a long, long time. So I'm an electrical guy, so I was able to fix this myself. So don't do this at home, I guess. But this is a Kepco 50-8M. That's what this is. Pretty robust, expensive machines. The Darlington driver, right down in there, there's two TO220s, and they're like over here. They drive this whole thing. So the debugging had unplugging one of this, and it was still up against the rail. Again, you got a lot of places. If you poke around here, you can either get shocked or, you know, get in trouble. These two big caps here, I got about 75, 80 volts across here and here. It's like about 150 across both. Big linear supply. A new toy. That's what I call it, a new toy.